this gets stuck, everything behind it doesn't run, because you need alpha-ketoglutarate to get to succinyl-CoA to get to succinate, right, all the way through. So if we have a direct pathway whereby we can make oxaloacetate, even though we're not doing these middle reactions right here, it means we can at least start over. So it's a very important pathway to evolutionarily preserve, because otherwise you could hit zero here in some circumstances, or low enough to zero that you could stop running the TCA cycle. And since we were talking about Dr. Tan, no ATP, you die, right? So we need this pathway just to make sure we don't ever have that happen. Okay, so those are the biggest. And then of course, these little bullet points right here are, this is what we do with all those intermediates, right? We've got our urea cycle, our gluconeogenesis, and our fatty acid and cholesterol synthesis. If you have deficiencies of this gene, you're going to see problems with fatty acid and cholesterol synthesis, gluconeogenesis, urea cycle. So again, when we talked about this on Monday, pyruvate to lactate is your anaerobic option. If you can't go acetyl-CoA to the TCA cycle and then go down through oxidative phosphorylation, your only option is lactate. And when you build up excessive lactate and you send it to the liver, you end up with lactic acidemia. Okay. All right. So I'm just going to assume you know this, but on the off chance you need a refresher, there they are. Methyl quercetyl-CoA carboxylase. Okay. So remember we talked about leucine in the last week, and we're talking about leucine stimulates muscle protein synthesis. You need biotin in order to break down leucine. There are all these different things that you see. These are genes in the disease state. They're very rare mutations, so I'm not going to quiz you on them. If you end up working in the NICU or the PICU, or there are genetic clinics, or you end up working with a gene counselor, you're going to go back and you're going to do more of this. But these are just generally to familiarize you with what might happen if the enzymes don't work. Propionyl-CoA carboxylase. Okay, so remember we were up there talking about methylmalonyl-CoA mutase. This is the step before. Propionyl-CoA carboxylase also ends up going to succinyl-CoA, which is an intermediate in the citric acid cycle. So we're talking about gluconeogenesis. Okay, so to treat, we restrict certain amino acids. And I will highlight this because there are two things that you want to do here, right? So these are certain amino acids, especially the branch chain ones, right? And also I won't say try. So why would, do you guys remember what carnitine does? Yeah, okay. So carnitine is what we use to import fatty acids into the mitochondria for oxidation. So propionyl-CoA, if we go through the steps, you don't want to build up propionyl-CoA because you can't go to methylmalonyl-CoA. So if you have as much carnitine as you can start pulling that into the mitochondria and oxidize fatty acids. So the more carnitine you have, the more you can get fatty acids in for oxidation, which helps with energy and things like that. Okay, so see, these are the